So we have implicit differentiation, which just means you're doing the derivative of an implicit equation. An implicit equation is one where it's not easy to isolate the y. Okay? It's not easy to isolate the y. It'll make sense as I go. All right, so here we go. Let's do some examples. The easiest way to teach this, I feel like, is with examples rather than showing you the formula right away. So that's what I'm going to start with here. So say we were doing the derivative of the old trusty x squared. If you notice, we're doing the derivative of x squared with respect to x. The x's match. That's good. You should know what to do in this case. All we have to do is use power rule. Done. Okay, but what happens if I did this? I want the derivative with respect to x of y squared. Okay, the x and the y don't match. That's a problem. The reason it's a problem is if you go back to the limit definition of derivatives, it's f of x plus h minus f of x over h. Everything's in terms of x. Okay, now we're mixing an x and a y, which would mean we would need a new limit definition of derivatives because we have multiple variables. By the way, what I'm saying right now, you do not need to know it. You need to know the formula, but I'm just trying to show you the ideas behind the concept. Okay, long story short, we can only use the limit definition that we have unless we want to create a new one, but I don't want to create a new one because it just seems annoying. What I'm going to do is use the one that I already have to solve this problem. And this is the equivalent of what I call like spreading your vegetables out on your plate. Did everyone ever do that when they were a kid? You had a bunch of vegetables on your plate, and to make it look like there was less, you kind of spread them out, and you hoped your parents were dumb enough to I shouldn't say that on recording. You hoped your parents would not realize that you didn't really eat any of them. It just looks like there's less, but it's really the same amount. Did anyone do that or no? Oh, yeah. Okay. It's like if you don't understand that because you're probably a good kid, or not that you're a bad kid, I'm just saying if you didn't understand, hopefully you understand that some kids did it, because it makes this whole process make sense a little bit more. So you can, long story short, the rule is you can only do the derivative if they match. Okay, you can only differentiate, I should say, if they match. So what we're going to do is we're going to force this to match by spreading out our vegetables. Here we go. What I'm going to do is I'm going to do, so let's see here. I'm going to do dy squared. I'm going to spread out my vegetables here, put a dx right here. Okay. Now, what values would I need to put here and here to make this still equal? What number could I put in both of those? Anybody? 1. 1. Very good. Okay. I could put a 1 here and a 1 here. Perfectly legal. I spread my vegetables out. It's just spread out. It's the same thing. Okay. But I don't want to put a 1 in there. The only thing that you can do the derivative of is when it matches. So what I'm going to do is I'm going to force this one right here to match. So I'm going to put a dy in here. But if I put a dy there, what do I have to put up here? dy, because dy over dy is 1. By the way, I didn't have to put a 1 in there. I could have put a 2, a 3, a 4. As long as it matches, it's going to cancel out. But if you notice, now I made it where this one matches. You're doing the derivative with respect to y. This right here can be rewritten. You don't really have to do it this way, but it can be rewritten. This is, again, why I have issues with that notation that we were talking about before. But this can be rewritten as d over dy of y squared times dy over dx. Okay. Well, now, if you notice what's highlighted right here, what I'm highlighting in blue here, if you notice, the y's match. So now what we can do is I can write the derivative of this as 2y, but you have to multiply by dy over dx here. Now you end up with something that's a little bit more simplified that you can actually work with. Okay, so the rule is this. Say you don't want to deal with all the spreading of the vegetables. Don't worry about it. All you have to know is the rule. If the y and the x don't match, you have to multiply by the dy over dx. Look at the symmetry between the 2x and the 2y, dy over dx. Everything's the same. 2y, 2x. Only the 2y also has an extra thing added to it. That's the rule. Okay, so if I said do the derivative with respect to x of y cubed, you just do the derivative like normal and then multiply by dy over dx. Does that make sense? So if you didn't understand the spreading the vegetables, don't worry about it. It's not even part of the class. I could have just taught the rule and said, have a nice day. But some people want to know where this stuff comes from. I know when I was a kid, I wanted that, so that's why I'm doing that. So the rule is for implicit differentiation is multiplied by dy over dx if it doesn't match. Okay? This is hugely important, especially if you're going to be an engineer, physicist, chemist, maybe not business major so much, but we're going to do this thing called related rates eventually in the next unit where you have to use this a lot. It's basically implicit differentiation in the real world. This is obviously not real world stuff. It's just y's and x's. It's just superfluous. But when you're applying it to real life things, you have to use the same implicit differentiation rule. Okay? So now we know the rule. We're going to apply the rule to a problem. And I'm just going to make this one up. I know I had all those problems written before, but this one you can just kind of make up anytime. So let's just I'm going to do an easier one first. Let's do x squared plus y squared is equal to 3. Okay? And the problem is going to state, what is the derivative of this equation? dy over dx. Okay? So let's do this. First thing that you need to do, it says dy over dx. That means we need a dx in there somewhere. So what we're going to do is differentiate both sides with respect to x. Okay? Remember what I said before, this is the hardest section of the unit, so make sure you definitely pay attention times 2. Okay? That doesn't make sense. Okay? If you're one of those people that like steps, don't, but if you do, the derivative, the first step is take the derivative with respect to x on both sides. Okay? Don't be one of those people that like steps, though, especially if you're going to be majoring in something crazy, because steps only get you so far. You have to understand what you're doing. So we're doing the derivative here and the derivative here. What's the derivative of x squared? 2x. Awesome. The derivative of y squared is 2y dy over dx. If you notice, we already did that one, so I should have picked a different one. That's my fault. But so I did the derivative of that already. You multiply by dy over dx. Now you might be thinking, wait, why does 2x not have that? Well, it really does. It's just invisible because it's dx over dx, which just cancels. So it's not there. It is there. You just don't need it. dy over dx does not cancel because they're not equal to each other. So you have to multiply it out. All right, next, what is the derivative of 3? 0. Very good. Okay, now, if you notice, what are we solving for? We're solving for dy over dx. So that's what we're going to solve for. We're going to divide both sides by 2. 0 over 2 is 0 still, so I'm just going to ignore that. Subtract the x to the other side and divide by y, and you end up with negative x over y. Now, what does this expression right here represent? What does that represent? The derivative of the equation. If you plug in any x and y in that, it's going to give you the slope of that tangent line at that point. So put in any x and y that are actually on the graph of the x squared plus y squared equals 3. You can graph that out. That equation right there will tell you the slope of any point on there. Okay, it's similar to what we were doing before, only there's a y in there now. Okay, you might be thinking, wait, I could have just solved for y on that one and did it. Yes, you're right. But they usually don't have it that way. This is just a warm-up type of problem. Okay. Any questions on what I did there? We're going to do a harder one now. I would say this is below AP level by a little bit. So we're going to go AP level now. Everyone's good? Yes. Yes. Okay. Just to kind of let's do it. Yeah. You want to see the graph of it? Is that cool? Yes. Yeah. All right. Cool. All right. So we have this here, and then I said the derivative. Let's do d of x because you can't write dy over dx in there. Is negative x over y. Okay. Oops. Hold on. Let's do, let's just do one that we definitely know for sure. What's the derivative at 0 root 3 there? 0, okay? Flat line, right? Now watch this. Let's do the, I shouldn't write it this way. This is going to be awkward because I can't write f prime in here. It'll yell at me. But I don't want to write f because people might think that f is equal to y. That's one of the great lies that they tell people is f and y are the same, which they usually are for like the lower math, but you can make f whatever you want. It could be defined with y as an input. If you've taken programming, you know what I'm talking about. But anyway, so we're doing 0, comma root 3. So watch this. I'm going to do f of 0, comma square root of 3. Okay, and it ends up being 0. This equation spits out the derivative at any point that's on this circle. So I can pick another point. Let's pick this one. What should the derivative be at that point right there? What? Undefined. Did someone else say that over here too? Yeah, undefined. It's going to go straight up and down. You should be able to imagine that in your head. Okay, well, it's root 3, comma 0. You can kind of see it's going to be negative x over y, so we're dividing by 0, but let's throw it in there anyway. Square root of 3, comma 0, undefined. Okay. And you can pick any one you want around the whole thing. It doesn't matter. But it still tells you the slope at that point, which is the slope of the tangent. Does that kind of make sense a little bit? Okay. Every time I show something, I like to show it numerically, graphically, and like algebraically. Algebraically is the most important because it's usually the hardest. I can teach, you know, a middle schooler a tangent line if it's 0 or undefined, but like to really know the, you know, breaking it down, that's where it gets really difficult. But it's still good to kind of visualize this stuff in your head. Okay. They say anytime you learn something, you want to apply it to something you already know. Because then now it's that thing that hooks you. Like it's already in your brain, like you knowing something. So if you learn something new, try to connect it to something else. That's why analogies are so powerful. Eventually, that connection will just kind of be supplanted, and that new thing you learned will replace it, and then you can connect something else to it. But try to always connect it to something else, whether it's understanding a graph, whether it's understanding you were in geometry before you were doing tangents, whatever. But try to connect things as much as you can. It'll help you understand it more. All right, we're still good with time. All right, let's do a more difficult one. I'm going to just throw you in the deep end on this and just give you an AP problem, so do not get mad. You know, a lot of you might get really close on this, which is awesome because it's the first time you've seen it, but you're not expected to get this right. Okay, here we go. Let's do 4, I'm just making stuff up, 4x to the third plus y cubed minus 7y equals x. And I'm going to say find dy over dx. Find the equation, or I'm sorry, expression for dy over dx. And then once you write it down, I'm actually going to start working it out just because I know there's some people in there that are like, why is he giving us this problem? I don't know what's going on. So I'm going to actually start working this problem out. But I don't want to spoil any fun for anybody, so do not look at the screen if you don't want a spoiler alert, I guess is what I should say. Here we go. I'm not doing a play-by-play on this because, again, I don't want to spoil anything. And remember, understand what it is you just found. You found an equation or expression that if you plug an x and a y in that is actually on that graph, whatever that graph looks like up there, it will tell you the slope at that point, whatever point you put in there. Okay, context. Understand what it is you just found. Sometimes AP will give you a problem like this and say, on what points does this graph have a zero slope, a horizontal tangent line? How would you answer that? So that original, what's in black at the very top, the 4x cubed plus y cubed minus 7y equals x. If I said, where does that equation have a horizontal tangent line? What would you do? Where's the slope 0? Go. Boom! Set the top equal to 0. Okay, and then just solve. That should be 1 equals 12x squared. You should be able to solve that no problems. Plus or minus the square root of 112, right? All you need to do. Make sure it doesn't divide out on the bottom. I've never actually seen it where it does, but if you plug that in at the bottom, you have to figure out what the y is, which could take you a year if you don't have a calculator based on the original equation. Usually you don't have to worry about it. Sometimes they ask you, where does that original equation have an undefined slope? That way you don't have to check it. What would you do for that one? You can take it if you want. Same thing, just with the denominator. You set the denominator equal to 0. Because the slope, if you're dividing by 0, it's undefined. So just set 3y squared equal to 7 and solve. Right? Trying to think of other curveballs AP has given people in the past. One thing you do have to understand with the free response is the average is usually around 3 out of 9 for each problem. There's 6 problems, 9 points each. The average is actually usually less than 3. Okay, that's why they have such a huge curve. But people will forget stuff like that. They'll be able to do this in their sleep, and then when they get to the point where it's like, find where it's undefined slopes, the kid's like, I don't know what that means. It means you're dividing by 0. So set the denominator of the slope equal to 0. The slope is undefined there. Slope at a point is undefined there. No questions on this? Okay. The only other way to make this really harder is to use a product rule. They never actually do anything over product rule, generally speaking. So a product rule version of this would look like this. I shouldn't have said anything because I would have been able to trick people. But it could have been like this: x squared y is equal to 3x minus 1. Okay, and then find the derivative of that. Do we want to do that? Is that okay for them? Yes, everyone's okay? Okay, let's do it then. Find dy over dx for this problem. But you do have to recognize, oh crap, I have to do product rule with x squared and y, because you're multiplying two functions together, essentially. 2 equations, or two variables are actually varied, they're not constant. That's what I should say. Same rules apply. You know what to do, you just got to do it. Oh, one thing that I hate, some students do this. They put dy over dx on that side. That makes no sense. Don't do that. It has to go in front. I didn't leave a lot of room, but it should go in front, so do not ever do that. AP would take points away, so I kind of have to as well. You just can't make up notation rules. I'm sorry. It'd be nice. Oh, wait, I shouldn't write this down. Oh, no, I just will. I don't want anyone to get mad. What's the derivative of y with respect to x? Should have simplified that out. Boom, dy over dx. You'd be surprised how many people get confused on that. It's just 1 times dy over dx, which is dy over dx. Thanks, Quinn. Good job not getting tricked. By the way, after that first red step that I have on the board, the rest is all algebra. All the calculus is done after the first step with these. It's crazy. It's literally crazy. I did all the derivatives, no more calc, it's all algebra. So when I grade these, the first thing I look for is that first step. I go, did they get the calculus right? Because you'd be surprised the crazy things I've seen people do with algebra. It's like, what were they thinking on that? All right, well, if there's no questions, I'm gonna move on here. All right, so one thing I have not talked about a lot, don't try to cheat either, is what happens if we did y is equal, so we're still doing implicit differentiation. We're doing arc sine of x, inverse sine of x. And I'm saying, what is the derivative of this? Now, I know I already gave you the formula. I shouldn't have done that. Usually I don't do that. You know, some people already know the answer because they studied this stuff already. But I want a full proof of what the derivative is. Okay? You have to actually work it all the way out. This is really, really difficult though, and we're gonna run out of time, so I'm just gonna kind of do it with you a little bit. It will still be very difficult though. But I just think this is so cool that you can do this. Check this out. What we're gonna do is we're gonna sine both sides. Okay? Now we're gonna do implicit differentiation. So what is the derivative of sine y with respect to x? So yell it out. We're all friends. Come on. Close. Cosine y, remember it's positive. Co is negative. Here is the derivative is 1. Well, we're trying to prove that the derivative is 1 over the square root of 1 minus x squared. So how do we get that? Just chime in if you have anything to say. There's probably multiple ways of doing it after hearing that. I mean, there's always multiple ways of doing these problems, but notice the red. I'm going to try to color code this. I'm going to create a triangle for the red. People never think to do this for whatever reason, but we're going to say sine of y is equal to x, right? So how do I draw that as a triangle? Pre-calc peeps. Sine of y equals x. Okay, this is like a memory thing then. Oh, go ahead. Thank you. Thank you. Go ahead. What's this side? Okay. Yeah. So then what is this value then? X. Then what's the hypotenuse if that's X? 1. Okay. Sine of Y is equal to X. Awesome. But what do we need? We need cosine Y. So what's cosine Y then? What's this equal to here? Don't write B. I shouldn't have wrote that in there because people are going to say B over 1. What's cosine Y with respect to X equal to? I already gave you the answer. It's square root of 1 minus X squared. If you were doing Pythagorean Theorem on this, that's what you would get for, let's just say this is B. You'd say X squared plus B squared is equal to 1 squared, which is 1. Okay, we're solving for B because it's B over 1. So B is going to be equal to 1 minus X squared, and then you do the square root of it to get rid of the square root. And then you resubstitute that in. And that's where that comes from. Isn't that crazy? Okay, you don't need to know all that. You need to know the formula. It's good practice to do all the stuff that I just did because it was implicit differentiation. But I just think it's cool how it relates like some trig stuff back into the derivative of inverse sine. And you're using the fact that, that's what's crazy about this. Sine Y, the derivative, we found that out. If you watch the video, I found that out using limits. But you're using that rather than trying to use limits to figure out the inverse sine. You're using some other part of it to reorganize it to something else. That's so cool. That's like the moral of the story with math. It's like you can't do something one way, change the form of it, and maybe you can do it some other way. Okay? So from black, you can't do anything, but to red, the first red step, sine Y equals X, you can do that. And then you're solving from there.